All projectiles fall at the acceleration due to gravity if they're falling towards Earth. What have I just said? I'm saying that any object that is in free fall, in other words, that is falling under the influence vertically only of its weight, any object in free fall on Earth will fall together with any other object. It doesn't matter if one is big and one is small, one is heavy, one's light, whatever. They will fall together if they are in free fall. Now that statement does not sound right, because I'm sure you've all seen something like maybe a feather and a stone, or a feather and a ball being dropped at the same time, and they don't fall together. But I've just said that if they were in free fall, they would fall together. What's going on here? Let's look at that feather that's falling normally here on Earth. It is not in free fall. Why not? Remember, in free fall, the object's weight is the only significant force acting vertically on it. But in the case of a feather falling, there is another very significant force, air resistance, acting upwards on that feather. And so the object is not in free fall. So it will not accelerate at the acceleration due to gravity, g. What about the ball? The ball also has air resistance acting on it in the opposite direction to its motion, in other words, acting upwards on it. But because of the size and the shape and the compactness of this ball and the fact that its weight is quite a bit more than the feather, its weight is much more than the air resistance. And so the air resistance in comparison to the weight of the ball is so little we can just ignore it. It's not significant. So in the case of the ball's weight is the only significant vertical force acting on it. So it is in free fall. It does accelerate at the acceleration due to gravity. So if I say all projectiles accelerate to Earth together at acceleration due to gravity, I'm not saying that a feather and a ball will fall to Earth together under the normal situations when you would do that. Because under the normal situations when you would drop these, the feather wouldn't be a projectile. But what about if we change things a bit so that both of them would be projectiles? Both of them would be able to be in free fall. Then we could test if my statement is really true. How do we get that right? We could use a vacuum tube. A vacuum tube is a glass tube which has had some kind of pump out a lot of the air. Preferably all of the air, but that's probably impossible. But most of the air that used to be inside that glass tube has been pumped out, and so there's a partial vacuum. In other words, nothing inside that glass tube. And if we now drop a feather and a ball at the same time through that vacuum tube, each of them will only be able to fall under the influence vertically of their weights, because there won't be air resistance, because there isn't air in it, or not much anyway. And so then we could see how they would fall if they are both projectiles, if they both are undergoing free fall. And when you actually do that, you do indeed see that the feather and the ball fall together. They hit the bottom of the tube at the same time if they drop together. If you don't believe me, then you watch it for yourself. Go to YouTube, this link, and you can see this being done. So what we've seen in this video is that all projectiles falling towards Earth, in other words in free fall towards Earth, accelerate at the same rate. And so they would fall together if they were dropped together, hitting the ground together. Doesn't matter what the projectile's shape or mass or anything else would be. Acceleration due to gravity is a constant on Earth.